Now we need to talk about matrix multiplication. And there's an important distinction I need you to understand right away. If I write A times B using the asterisk symbol, that's element-wise multiplication. Position 0, 0 of A multiplies position 0, 0 of B. Position 0, 1 of A multiplies position 0, 1 of B, and so on. That's not matrix multiplication in the linear algebra sense. For true matrix multiplication, what you learned in linear algebra, where you do the dot product of rows and columns, we use the at sign symbol. That's Shift 2 on your keyboard. So I write A, at symbol, B. There are actually three ways to write matrix multiplication in Numpy. First, at symbol B, that's the most common and cleanest way. Second, using dot method, where you write A, dot, and then use dot method to pass B in parentheses. Third, use dot as a form of NP function. In that case, after calling dot function, you pass A, comma B in parentheses. All three do the exact same thing. They all perform true matrix multiplication. Use whichever style you prefer, but I usually use the at symbol because it's shortest. Now, here's the critical question that shows up on exams. Can we multiply these matrices? Not every pair of matrices can be multiplied together. You need to check the inner dimensions. Let's say A has shape m by n, and B has shape n by p. Notice I wrote the same letter n in both, A's number of columns and B's number of rows. Those must match for matrix multiplication to work. If they match, the result will have shape m by p. You take the rows from the first matrix and the columns from the second matrix. Let me give you examples. Say matrix E has shape 3 by 3. Matrix F has shape 3 by 2. Can we do E at symbol F? Check the inner dimensions. E is 3 by 3, so its inner dimension, the number of columns, is 3. F is 3 by 2, so its inner dimension, the number of rows, is 3. 3 equals 3. Yes, we can multiply. And the result? E has 3 rows, F has 2 columns. The result is 3 by 2. Now say matrix E has shape 3 by 3. Matrix F has shape 2 by 2. Can we do E at symbol F? Check the inner dimensions. E has 3 columns, F has 2 rows. 3 does not equal 2. This gives an error. We cannot multiply these matrices. Now let me show you how to actually calculate matrix multiplication by hand, because you might need to do this on an exam. Let's say I have a 2 by 2 matrix with elements A, B in the first row and C, D in the second row. I'm multiplying it by another 2 by 2 matrix with elements X, Y in the first row and R, Z in the second row. Before I show you the calculation, let's apply what we just learned. The first matrix is 2 by 2. The second matrix is also 2 by 2. What are the inner dimensions? The first matrix has 2 columns. The second matrix has 2 rows. 2 equals 2, so yes, we can perform this multiplication. And what will be the shape of the result? The first matrix has 2 rows. The second matrix has 2 columns. So our result will be a 2 by 2 matrix. Now we need to compute each element of that result matrix. We have 4 positions to fill: 0, 0, 0, 1, 1, 0, and 1, 1. To find position 0, 0 of the result, I take the first row of the first matrix and the first column of the second matrix. I multiply corresponding elements and add them up. That's A times X plus B times R. To find position 0, 1, I take the first row of the first matrix and the second column of the second matrix. That's A times Y plus B times Z. To find position 1, 0, I take the second row of the first matrix and the first column of the second matrix. That's C times X plus D times R. To find position 1, 1, I take the second row of the first matrix and the second column of the second matrix. That's C times Y plus D times Z. So the result is, first row has AX plus BR, then AY plus BZ. Second row has CX plus DR, then cy plus dz.
So we're always doing row from the first matrix against column from the second matrix?
Exactly! Row from the first, column from the second. Multiply the corresponding elements, then add them all up. That gives you one position in the result. Repeat for every combination of rows and columns. Let me work through a concrete example with actual numbers so you can see the full process. Matrix A. First row is 1, 2. Second row is 3, 4. Matrix B. First row is 5, 6. Second row is 7, 8. First, let's verify we can do this multiplication. A is 2 by 2, 2 columns. B is 2 by 2, 2 rows. The inner dimensions match, so we can proceed. The result will be 2 by 2, meaning we need to calculate 4 values. Let's calculate A at symbol B. Position 0, 0. I take row 0 of A, which is 1 and 2. I take column 0 of B, which is 5 and 7. I multiply and add. 1 times 5 plus 2 times 7. That's 5 plus 14, which equals 19. Position 0, 1. Row 0 of A is 1, 2. Column 1 of B is 6, 8. 1 times 6 plus 2 times 8. That's 6 plus 16, which equals 22. Position 1, 0. Row 1 of A is 3, 4. Column 0 of B is 5, 7. 3 times 5 plus 4 times 7. That's 15 plus 28, which equals 43. Position 1, 1. Row 1 of A is 3, 4. Column 1 of B is 6, 8. 3 times 6 plus 4 times 8. That's 18 plus 32, which equals 50. So A at symbol B gives us first row 1922, second row 4350.
What if we flip it around? Could we do B at symbol A instead?
Great question. Let's check. B is 2 by 2, so it has 2 columns. A is 2 by 2, so it has 2 rows. 2 equals 2. So yes, B at symbol A work as well. And this brings up a critical point you must remember. A at symbol B is not the same as B at symbol A. Order matters in matrix multiplication. Let's see the results for B at symbol A. The final results gives us first row 23, 34, second row 31, 46. Compare that to A at symbol B, totally different results. Same matrices, different order, completely different answers.